This is the AQA A-Level Chemistry Amount of Substance topic. We're on part 6 of the video walkthrough, and on this we're looking at the final 2 calculations within this topic, specifically percentage yield and atom economy. As always, have a look at the examples that are on here, try to answer the questions, pausing the video as you go, and then you get a chance to review and see how effectively your learning has been going and whether there are any areas that need to be developed. So, when you're ready, have a look at the questions here. This is atom economy. So with atom economy, we are looking at the mass of desired product. Essentially what we're saying there is the collective molecular masses of the product that is useful. In the first example here, it's NH3, ammonia. And then we're dividing that by the total for the reactants. So we add up the MRs for all of the reactants. In this case, that's 3 H2s and 1 N2. Now, this is actually a very simple one straight away because all of our reactants are going to make that NH3. So we've got total useful product. We count nitrogen, 3 hydrogens is 17, 2 moles of it, that's 34. But we're going to divide that by 34 and multiply by 100, giving us an atom economy of 100%. And if there's only one product, the atom economy is guaranteed to be 100%. The next one, slightly more complicated. This is the breakdown of glucose into into ethanol and carbon dioxide. And in this case, we've got 2 ethanols. That gives us a total of 92, so that's 2 46s. And the total molecular mass of the glucose we started with is 180. So if I take my 92 over 180 and multiply that by 100, I get an atom economy of 51.1%. Another example that we have here is magnesium reacting with water, and we're saying here that water is, magnesium oxide and hydrogen is the useful product. So within the useful product, we've got 2 as the total mass from the H2. My total for the reactants is 24.3 plus 18. That takes us to 42.3. Multiply that by 100, we get an atom economy of just 4.73%. Now, that gives rise to the question, how could we manage industrially reactions that have a very low atom economy? Well, there's a number of ways that we can do that. One, we might decide we're going to recycle the reagents. We're going to keep reacting them until they react. But we might also decide to sell the secondary product. In this case, that would be magnesium oxide. There would be companies that would buy that magnesium oxide, and that's going to add to your overall profits. Moving on to percentage yield, and again we've got in the blue box how this is carried out, and we've got 2 really simple examples that don't feed into much chemistry. We make 9 grams, we expected 12, what's the percentage yield? Have a go at these 2 questions and then we'll review. So, in the first example, the specific product formed, we got 9 grams, we expected 12. So 9 divided by 12, multiplied by 100, 75%. On the next one, numbers are a little bit more fiddly. We expected 23.8, we only got 13.6. That gives us a percentage yield of 57.1%. You must be really, really careful to differentiate carefully between atom economy and percentage yield, because it can be quite easy to get mixed up. The reality is that for percentage yield, you are likely to have this as the end of a bigger question. And specifically, we're looking at reacting masses. So if we take the example that we have here, I've got aluminium reacting with oxygen to make aluminium oxide. I've got my mass of aluminium. Be careful not to use the 18.4. That's what we would expect to make. Now let's take a look. Let's see what happens as we go through. The aluminium, 13.5, with an MR of 27 means that I've got 0.5 moles. I then look at the equation, which has a 4:2 ratio of aluminium to aluminium oxide. Now that means that for the half mole of aluminium, I'll make 0.25 moles of aluminium oxide. Aluminium oxide has an MR of 102, and that tells me that we should have made, my theoretical mass was 26.5 grams. We didn't make 26.5 grams, we only made 18.4. So I now go back to my percentage yield calculation. My 18.4 I actually got, divided by 26.5 I should have got, multiplied by 100, and we get 69.43%. Here's another one to have a go at. Once again, it's reacting masses. Let's draw out the table. Lithium, we started with 14 grams. My MR is 7. I've got 2 moles. My mole ratio is 4 to 2 again, which means 1 mole of lithium oxide. Lithium oxide has an MR of 30. So 1 multiplied by 30. I should have made 30 grams. The question tells me I only made 26. So 26 over 30 multiplied by 100, 86.67%. Let's move on to the next question. And once again, we build our table. We care about the Al and the Al2Cl6. I can put my mass of aluminium in, which is 27. Its MR is 27. So a nice round number. I've started with 1 mole. My mole ratio here is 2 to 1, which means I've got half a mole of Al2Cl6. And Al2Cl6 has a relative molecular mass of 267. Multiply those together and I get 133.5. Now you can actually see that had already been provided, so all of that is actually unnecessary on this question, but it's good practice to see how we get there. My actual mass was 90, divided by my theoretical maximum mass, 133.5, multiplied by 100, and we get 67.42%. That takes us to the end of the amount of substance topic. There are 6 videos in total, covered a huge number of different calculations and skills. Thank you very much for listening. Goodbye.